Okay, this week is essentially calculations. There's not a whole lot of field practice for a standard test method for density, which is unit weight, yield calculations, and then also that third air content calculation or the method that we talked about. The first two are measurements of air content using tools. This is a determination of air content based on calculations from the density measurement. So recall the density can be measured in just a plain density pot like you see in these first two pictures, or and more commonly, the density test is performed in concert with the air pressure method test using that same pot. And we're just going to work through a couple example calculations using this example data provided. And we're going to say that the volume of the pot being used is one of the larger ones, a half, basically 0.502 cubic feet. And remember, this is probably a half of a cubic foot pot, but you do calibrate these pots to determine what the actual exact volume is using water, right? A material of known density. So that was measured to be 0.502 cubic feet. The mass of that pot was weighed to be 19.3 pounds. And then in the density preparation, the mass of the pot plus the concrete equals 93.2 pounds. We're dealing with an 8 cubic yard delivery of concrete from the batch plant, and the batch delivery ticket indicates a total mass of concrete being delivered of 31,869 pounds. The theoretical density of the concrete being delivered, determined by the batch plant, is 152.5 pounds per cubic foot. And some of this information comes along with each truck that shows up on a site. This is just a kind of a quick example concrete batch ticket that I just Googled. I don't know that it represents an actual job anywhere. But some of the information that you'll see on these tickets is right here the size of the delivery, the yield, I guess, of the delivery, and then down here we have the total mass of the concrete being delivered. And what you can do is use the information on this ticket to determine if you're getting the relative amount of material that you're paying for. If you're paying for 4 yards of concrete, are you actually getting 4 yards of concrete? And you do this based on the density determinations from your pot measurements. So we're going to work through the 4 calculations that the ACI method goes over for this section C138. And again, we're using this example data here. And the first is the unit weight, or the density of your concrete. And this is a fairly simple one. You're going to be expected to verbalize this during the practical test, but not necessarily run through the actual calculation. And the density is just the mass of the pot plus the concrete, right, minus the mass of the empty pot divided by the volume of your pot, right? Mass over volume. And using our numbers, we would get 73.9 pounds of actual concrete when we subtract out the empty pot, divided by the 0.502 cubic foot size of the pot, for a density of 147.2 pounds per cubic foot. Yield is basically how much concrete is being delivered in this delivery truck, and there's 2 yields that they're going to go over in the calculations for the ACI manual, the batch yield and also the yield per cubic yard. And you can do the batch yield expressed in cubic feet or also expressed in cubic yards. And the yield batch expressed in cubic feet is the mass of your truck over the density of your concrete. Our total mass in this example is 31,869 pounds, and in the previous step we just determined the concrete to be 147.2 pounds per cubic foot, or we are receiving 216.5 cubic feet of concrete. Obviously we've been doing this now in our earthwork calculations and also some other calculations in this class. When you want to convert cubic feet into cubic yards, you do your dimensional analysis, and we know that there are 27 cubic feet for every 1 cubic yard. So 216.5 divided by 27 gives us 8.02 cubic yards of concrete being delivered based on the density. So the yield per cubic yard is how many cubic feet are we getting per cubic yard, right? It's the actual yield divided by the theoretical or the design yield, right? And we determine the actual yield to be 216.5 cubic feet. It was an 8 cubic yard design batch, right? That came from here in our project data. And 216.5 divided by 8 cubic yards tells us we're getting 27.06 cubic feet per cubic yard. And we can express these numbers then in a relative sense in our next step. Step 3 is calculating relative yield. And relative yield is simply the ratio of the actual volume of concrete to the design volume of concrete. And you can express relative yield in, or it's a number, it's a unit list number because it's a ratio, so you can determine it from yards or feet. And so our relative yield in this particular example is the actual volume of concrete we just computed in step 2 was 8.02 cubic yards divided by the design or the intended delivery, which an 8.0 cubic yard batch gives us 1.002. We would also get that if we took the 27.06 cubic feet divided by our theoretical number of cubic feet per cubic yard, which is 27, gives us 1.002. Essentially that's rounded off to 1.0 or 1.00. And where this number comes important is its relationship to 1. If your relative yield is greater than 1.0, you're actually receiving more concrete than you're paying for, because you're paying for the delivery that comes off of that ticket. If that relative yield is less than 1, you're actually receiving a deficiency. So that might be where you argue for a cost adjustment for your client, or if you're the inspector on site. Okay, and then last step, step 4, is determining air content by measurements here. And this is the gravimetric determination of air content. And our air content can be determined by the theoretical density of the concrete minus the actual density that we measured back there in step 1, divided by the theoretical density. And what theoretical density is it would be the density of all of those materials in that concrete if air were not considered and air were removed. Actual density that we do measure does include air, right? Because we have that entrained air, you know, those microscopic air bubbles. So theoretical density is always higher than actual density of concrete. And theoretical density will come from the batch plant, the mixed design. So theoretical density has to be given to you. And in this particular example, I just gave you 152.5 pounds per cubic foot. So we take our 152.5 minus the measured from step 1, 147.2, divided by that theoretical gives you a decimal value of 0.035, because we want to express air content in terms of a percentage, right, multiplied by 100, or 3.5% air content. And if there is question on the validity of your air pot or even rollometer, if you're doing rollometer, this is a method that you could use to check those. And this is probably the most accurate method as long as you're filling up your pot and getting your unit weight correctly, because you have no tools to come out of calibration. You have no needles to read. You don't have a rollometer that could be potentially leaking. So not a bad idea to run this if you get a chance.